Section 4.6 is on the quadratic formula and discriminant. Given the quadratic equation ax squared plus bx plus c equals 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's take a look at how this works. Solve each quadratic equation using the quadratic formula. I find it helpful to start with by identifying a, b, and c. So a is 1, b is 6, and c is negative 16. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. And I'm not going to bother to multiply by 1, all over 2a. So that's going to give me negative 6 plus or minus the square root of 36, negative times a negative, plus 64 over 2, or negative 6 plus or minus the square root of 100 over 2, or negative 6 plus or minus 10 over 2. So that means that x is equal to a negative 6 plus 10 over 2, or 4 over 2, or x equals 2. X is also equal to negative 6 minus 10 over 2, or negative 16 over 2, or negative 8. Cool thing about the quadratic formula is it always works. It always gives you an answer. Sometimes graphing is imprecise. Not everything can be factored. Completing the square works, but it's a little messy. But quadratic formula is great. Just plug in a, b, and c, and then PEMDAS it. Here's a second example. X squared plus 34x plus 289 equals 0. A is equal to 1. B equals 34, and C equals 289. So x equals negative 34, negative b plus or minus the square root of b squared. Off the top of my head, I don't remember what 34 squared is. 1156 minus 4 times a times c, all over 2a. So negative 34 plus or minus the square root of 1156 minus 4 times 289. Oh, look at that, it's 1156. Wow, that's very cool. All over 2, or negative 34 plus or minus square root of 0 is 0 over 2, which means that x just equals negative 34 divided by 2, or negative 17. So sometimes when you do the quadratic formula, you may end up with just one solution, in this case negative 17. Let's try this one. So a is 3, b is 5, c is 1, and x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a, or negative 5 plus or minus 25 minus 12 over 6, or x equals negative 5 plus or minus the square root of 13 over 6. And that's my final answer, because I can't take the square root of 13. I can't simplify it any further. So this means that I'm going to have two irrational roots. Notice it's not going to be two nice numbers, because I can't figure out what the square root of 13 is exactly. And let's take a look at this example. A is 3, b is 5, c is 4. So x equals negative b plus or minus the square root of b squared minus 4 times A times C all over 2A. Negative 5 plus or minus the square root of 25 minus 48. Is that right? All over 6, or negative 5 plus or minus the square root of negative 23 over 6. And I can't leave my answer that way. I can't leave the negative under the square root. So that's going to be like a square root of negative 1, which will be an I that comes out front. So my final answer is x equals negative 5 plus or minus I square root of 23 over 6. And yes, it's kind of a funny looking answer, but that's correct. So let's go back and take a look at these problems that we did here, these 4 examples. So in the first one, I got 2, I would call nice numbers, 2 integers, 2 and negative 8. For my second one, I got 1 integer, negative 17. For my third example, I got 2 irrational numbers because I couldn't simplify the square root of 13. And then for my fourth example here, I got 2 imaginary or 2 complex roots because I had a square root of negative 23 that I had to pull an I out of. And that's actually what's going to happen. Those are kind of the 4 different cases that you can get. And you can figure out what sort of answer you're going to have by looking at the discriminant. And the discriminant is just b squared minus 4ac. It's the stuff that's underneath the radical. And its value, oh, that is a typo right there. Here we go. Its value can tell you the number and the type of roots that a quadratic equation has. So for example, if discriminant is greater than 0 and it's a perfect square, you're going to have 2 real rational roots like we did in our first example. If b squared minus 4ac is positive, so again the positive discriminant, and it's not a perfect square like we saw in our third example, you're going to have 2 real irrational roots. That was the one that had the square root of 13 in it. So that means that your graph of your parabola is going to cross the x-axis in 2 distinct points. In the first case, you're going to get nice integer numbers. In the second case, you're going to get irrational numbers, something with a square root that can't be simplified. If the discriminant is equal to 0, then you're going to have 1 real rational root. And that was like our second example where x equaled negative 17. That means that the graph of the quadratic function is going to hit the x-axis in just 1 point. And if b squared minus 4ac, if the stuff underneath the square root sign is negative, you're going to have 2 complex roots. Like we saw in our last example, there'll be an I in your final answer. So let's take a look at just a couple more examples here. And this says for each quadratic function, find the value of the discriminant, describe the number and type of roots, then find the exact solutions using the quadratic formula. So our first step is just to find b squared minus 4ac and see what that tells us about the number and type of roots we're going to have. So a is negative 5, b is 8, and c is negative 1. So b squared minus 4ac, b squared is 64 minus 4 times a times c is going to give me 64, and that's a minus, and a minus is going to give me a minus 20. So the value of the discriminant is 44. So what does that tell me about the number and type of roots? That tells me that I'm going to have 2 irrational roots. Go back to the table here. It's a positive number, but it's not a perfect square. So I'm going to have 2 real irrational roots. Okay, now I need to find the solution using the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac. I already did that, 44. All over 2a. Let's clean that up a little bit because I can simplify the square root of 44. It's not a perfect square, but it can be simplified. So negative 8 plus or minus, I can take a square root of 4 out of that, which is a 2, square root of 11 over negative 10. And now I can divide each of those, the negative 8, the negative 8, the 2, and the negative 10, I can divide those by 2. So x is equal to negative 4 plus or minus the square root of 11 over negative 5. And those are my two real irrational roots. And let's take a look at our last example here. A is 2, B is negative 6, C is 9. Let's find our discriminant, b squared minus 4ac. So b squared is 36 minus 4 times a times c gives me 36 minus 72, or negative 36. That's the value of the discriminant. Because it's negative, that means I'm going to have two complex roots. In other words, I'm going to have an I in my final answer. Now, let's solve this using the quadratic formula. X equals negative b plus or minus the square root of, I already found b squared minus 4ac, all over 2a, or that's going to be 6 plus or minus square root of negative 36 is 6i over 4, and I can divide each of those by 2, so 3 plus or minus 3i over 4, or I'm not sure which way they prefer to write it, 3/4 plus or minus 3/4 I. Remember, that second way of looking at it shows you the real part and the irrational part. I'm sorry, the real part and the imaginary part. So in this section we took a look at the quadratic formula and how to use it to solve a quadratic equation. We also looked at the discriminant, which can tell us, just doing a part of the problem, tells us the number and the type of roots that we're going to have in our solution.